Good morning. These are the 1.1 lecture notes for informal geometry. We are going to start with defining some terms. So in a system of logic, you will define terms as an operating position to construct arguments and create different constructs. So let's start with points. Pretty foundational for geometry. So let's go ahead and do an example. So here is a point. We'll call it point A. Here it could be another point. We can call that point B. We generally indicate points with an uppercase letter. Okay. Now I know we're drawing the point like that, and that's really just so you can see it. But in our system of Euclidean geometry, it has no size. And you might be like, well, that's weird, it doesn't have any size. Well, just think of it this way. It is defining a definite location, or indicating a specific location. And that might help you think about it. You know, it doesn't have any size, so it's really small. So if we put it on something almost like a laser pointer, you can get to a really, really specific location, not just, you know, Petoskey, but you can drill way, way down into this room at Petoskey High School, etc., etc. All right, so we have our drawing. We have how it's written, uppercase letter, example A, B, X, Z, whatever you want. Has no size, indicates the specific location. So that is point. All right, so our next definition here that we're going to start with or introduce is a line. Okay. And again, you might think it's a little ridiculous that we need to define these things. Just remember, when you're making any strong argument, which a lot of geometry is and math is, you need to clearly define your assumptions so people know where you're starting from. Okay, so let's go ahead and work this over, and let's get an example. Okay, so let's have point A and point B, and I just chose two random points. It doesn't matter where you put them. And so to construct a line with 2 points, we just get our straight edge out and clearly draw our line. Okay, so how do we write this? Well, a couple of different ways. Okay, we have line AB, and we're going to go ahead and draw a little line on top so people know what we're talking about. Now, if we have line AB, then we could also have line BA, because it goes forever in either direction. Now, there's one other way that we can do this. We pick a lowercase cursive letter, for example, because it's a line. I'm going to go ahead and pick L, but you could pick M or Q or whatever really you wanted. And so we'll go ahead and throw that on there. So this is also line L. So this is how we are going to, this is how we're going to write it. Fancier word for that is notation. So we're going to use some notation there. Alright, so we've got that. Properties. Well, what do we notice about the line? Well, I had you use the straight edge because a line is straight. Alright, and very much like the points, okay, instead of having no size, it really has no thickness. Okay, we're not defining a sidewalk or anything like that. It is something that just connects 2 points. And you'll notice right here on the ends, these arrows mean that means that it goes on forever. And the way that we can write that in math is it is infinite. Okay, and we'll introduce some other cousins of the line, sisters of the line, you know, next, but a line by definition goes on forever. Okay, so that is line. Okay, our next geometric figure, our next geometric assumption, base, whatever we want to call it, is a segment. Okay, so a segment is one of these cousins or relatives of the line. So let's go ahead and get 2 points here. And let's call it X and Y, change it up a little bit. Okay, so I'm going to connect these two. And the difference between a segment and a line is that the segment just stops. Segment just stops. It is not infinite. Not infinite. Alright, so it is just part of a line. And very clearly, so if it's part of a line, then it has 2 endpoints. Alright, so that's what we're looking at for segment. So how do we write this? Well, very similar to a line, we have segment X, Y, and then instead of the line on top, we have the segment on top. Okay, now if we can write it segment XY, we can also write segment YX. So there you go, segment. Okay, cousin of the line. We've got another cousin of the line coming up in 1 second, and after that then we'll define a plane and we will be all done. Alright, so we've got line, segment, and then the next one is a ray. Okay, so ray. And hopefully you guys have seen some of this before, and that's never a bad thing. That's a good thing. So a couple points, and here we go. And let's call that JK. Although I'm not, get it? So this is another cousin of the line kind of situation. So I'm going to draw it this way, and it'd be helpful if you would draw it the same for consistency's sake, at least to start. And the more we work with it, the more comfortable you'll get with it. So I have array. So segment had 2 closed endpoints, line had 2 open endpoints, and then this has 1 closed and 1 open. Okay. So array, because again it's part of a line. And obviously from our drawing it has 1 endpoint. Okay, and so it has 1 endpoint, so one end stops and the other end, other or opposite, this is a good term to introduce, and extends infinitely. And I'm going to go ahead and use that infinity sign just to save some time and get comfortable with notation. So other opposite ends extends forever, okay, or goes on forever, however you want to write it. All right. So that is that. How do we write it? Well, this one is a little tricky because we always draw the array notation from left to right. Alright, so if we're drawing it from left to right, it really doesn't make sense if we say J goes on forever, because J does not go through point J forever. It goes through point K forever, and it starts at J. Okay, so this one's a little bit different, and this will be on assessments, and we'll be working with this. And it's one of those things that's straightforward enough, you just got to know. And that's why we do these note cards. Just some things in math, boom, you just got to know, and then you can move on. Okay, so that is array. Okay, so the next figure is a plane. Okay, and really the best example of a plane is just this note card. So if you pick this note card up, this is a 3-dimensional plane. Okay, it is a flat surface. Now ours has a little thickness, but in geometry the plane has no thickness. Okay, and it'll just extend forever in all directions. So this is a really good model for a plane, is this note card. So think of a plane, it can be tilted any way, okay, and that's really the best example I can give you. So let's go ahead and show you how we would draw one. Okay, so I am going to this guy out and do something like that, and something like that, and it doesn't have to be perfect, you know, but using the straight edge is, for me, is a good thing. I like stuff pretty clean, so it's a good habit to get into when you're doing that stuff. So again, not perfect, but you know, we got the idea. It's kind of like a card, except it's tilted a little bit. So plane now. Plane has 3 points. That's what defines a plane. So 3